quick exercise here. It's a little bit of a side, and actually might be two asides in a row, but hopefully we'll get back to the point real quick. Add up consecutive odd numbers. So the first one doesn't require anything, but the next one, 1 plus 3 is 4. Now, from here on out, you don't have to do 1 plus 3 is 4, plus 5 is 9. You could just go, this was my previous answer, plus 5 is 9. So this was 9, plus 7 is 16. This was my 16, plus 9 is 25. Now, why we did this is because it's kind of an interesting fact that the sum of odd numbers turns out to be perfect squares. Here's a table of perfect squares, and for what we need them for, this is probably all you need is the first 4, maybe 5. Some other things that we might do in algebra class, you might need past 10 squared, but for this, this would be all you need to know. Just take a look at that. You know, the squares 1, 4, 9, 16, 25, and that's what I get by adding up odds. Well, why did we do that? Well, it's right here. One of the quickest ways to graph the parabola, once you add the vertex, and from vertex form, it can be really, really quick, is we go over 1, up 1, over 1, up 3, over 1, up 5, and you probably guessed it, if you had to get the next point, it'd be over 1 and up the next odd number, which would be 7. And you know, just do that on the other side. Up 1, up 3, up 5, up 7, and we'd probably never get to this, but it's there just in case we have a really large graph, or we have a lot of detail in that graph. So 1, 3, 5, 7. Just remember that, 1, 3, 5, 7. Now that is not always what happens, but it's part of the rule, and I'll explain that rule in a little bit. So let's get to our second example. We have our vertex is going to be at, well, that is a positive 6. So that means I had to go to the left 6. So here's where I'm putting my vertex. I'm going to label it vertex this time. Make that stand out. Vertex, most important point on the parabola. And then my y move is up 2, which is plus 2. So remember, the opposite of the x still, same as the y. Negative 6, positive 2. So it's here. And we're going to go do the table again. We're going to go to the x value and go 1 away. Plug that in. Negative 5 plus 6 is 1. 1 squared is 1. But that 1, when it comes out, gets that negative, or multiplies that negative. So I have negative 1 plus 2. Negative 1 plus 2 is 1. So if I graph that, that's 5 to the left and 1 up. That's the vertex. It opens down. In general, it's going to look like this because that a value is negative. It opens down. It has a maximum. So give me a second here. Here's my axis of symmetry. And I can already start flipping these points over. I can have a point right here. I've already got the coordinates for it all set to go. It's going to be 7 to the left, 1 up. And that A rule that we just did, over 1, well, this time it's down 1 because it opens down. Over 1, down 1, over 1, down 3, 1, 2, 3. It's right there. So that's negative 4, negative 2. And you could check the math. Plug that in. Negative 4 plus 6 is 2. 2 squared is 4. Then you have that 4 comes out, multiplies this negative, so it's negative 4 plus 2 is negative 2. It works. So over 1, down 1. Over 1, down 3. Over 1, down 5. So that'll land me here at negative 7. And that's all I have room for. So that's negative 3, negative 7. And I could go to the table and reflect everything. So it looked like this. So it's going to go negative 8, negative 2, and it's going to go negative 9, negative 7. or just 3 away. Go another 3 right here. So lots of ways we can get our points. Oh, I missed this one. And then we try to make a nice smooth curve. One of the hardest parts. Give it arrows, and we're done. Okay, so now we're going to learn a little bit more about the A rule. Okay, here's A, it's -2. You're going to find out that 1, 3, 5, 7, it doesn't happen just exactly like that all the time, but we will figure out what the difference is, and when we do, we'll finally have the final rule nailed down so that you can graph all parabolas from vertex form at any time. So we have +4 for my vertex, +8, plot it, and then I'm going to go 3 or 5. Maybe you'll like 5 because you'll have positives. 5 minus 4 is 1. 1 squared is 1. That 1 comes out, multiplies a -2, so it's -2. -2 plus 8 is 6. 5, 6. Here's my axis of symmetry. Let me change the color on these points. Let's flip this one over 1. That meant it should have been at -3, or sorry, 3 and 6. And I'm going to put in 6. 6 minus 4 is 2. 2 squared is 4. 4 multiplies a -2. That's -8. -8 plus 8 is 0. So right there. And reflect that over, 2 away from the axis of symmetry, 2 away from the axis of symmetry, and I not only get that point, but I get this one as well, 2, 0, and I probably have room for another one. Put in 7, 7 minus 3 is, or sorry, 7 minus this 4 is 3, 3 squared is 9, this 9 comes out, multiplies a -2, that's -18. -18 plus 8 is -10. Yeah, just fits onto my graph. And if 7 works as an input, so does 1. If I put in 1, I should get out -10. Try to be really smooth right at the vertex. Don't make it look V-shaped at all. Yeah, sort of bad towards the end, but I'm not going to fix it. Here's the most important part of it. Really hard to draw with a mouse. You could probably do much better with a pencil. Probably better be a pencil, not a pen. Maybe should have mentioned that. Alright, so take a look at the A rule this time. I'm not going down 1. I'm going down 2. I'm not going down 3. I'm going down 6. I'm not going down 5, I'm going down 10. So 2, 6, 10, instead of 1, 3, 5. And maybe you figured it out by now, that A value had a magnitude of 2. So what you're going to do is this value, or the sign here just tells you opens up or down. It'll tell you whether the vertex is a max or a min. It's the max when it's up. If, I'm sorry. If it opens down, it's got a max. As in this graph, that's the topmost point, the maximum point. If it opens up, it has a min. So that's what the negative tells you. Then the other part of the A value, the magnitude, it tells you a multiplier for your A rule. So you do your 1, 3, 5, 7, and the higher A is, the fewer of these numbers you're going to be able to fit on because it's just going to take off that fast. So we're going to multiply A times 1, A times 3, A times 5, A times 7, and in the case of A is 2, that's going to be 2, 6, 10, and we're rarely going to be able to get to 14. So there you go. Those are all the rules for graphing parabolas from vertex form. Just back to the ones where a was 1, it's just 1 times 1, 1 times 3, 1 times 5. Simple. Alright, last example, and then one try it problem. Vertex at positive 2, negative 3, and I'm just going to skip that table, and I'm just going to go to the A rule. Instead of going over 1, up 1, I'm going to go over 1, up a half. Remember, when the A value is between 1 and 0, it starts to get wide. And then I am going to go over 1, and instead of up 3, I'm going to go up 1/2 times 3, which is 1.5. So there's 1.5. I'm just going to reflect this over. There's my axis of symmetry. I'm just not drawing it in this time. And I could probably get some more points in now. Instead of going over 1 and up 5, I'm going to go over 1 and up 2.5. 1, 2.5. And then reflect that over. It's going to be there. That's probably enough, but I'll do one more. Instead of going over 1 and up 7, over 1 and up 3.5. 1/2, 1.5, 2.5, 3.5. Okay. Pretty much done there. Nice smooth curve. Arrows. It's just that easy. It can be just that quick, even when A values are 1/2. So long as you can multiply by halves in your head. If they get more difficult, like 3/4, well, maybe you need a calculator for that. Okay, try it. Alright, so here it is almost finished. Vertex at -5, -9. A value at 3, it opens up, over 1, up 1 times A, 1 times 3. Over 1, up 3, over 1, up not 3, but 9. Over 1, not 5, but 15. And then connect those points in a nice smooth curve if you can, and you got your parabola.